In this section, we're going to be building a table classification service to provide a REST API in order to classify table data. In this section, we're going to be taking a look at a table classification configuration to build up a table-driven data model, a REST API definition in YAML. We're going to train models in Docker containers, and then we're finally going to wrap up our service and make a prediction server inside a Docker container. And now in this video, we'll take a look at table classification configuration. We'll start off the video by getting the project source code, and then we'll take a look at the table classification configuration YAML, and then we'll use this YAML and transform it into a table model like we learned about in previous videos. And then finally, we will look at a program to build a command line interface to tie this all together. Here's the URL to the GitHub repository that goes with this section. Feel free to clone this with any Git tool you like and get it to your computer locally so you can follow along. We'll start off by taking a look into the lendingclub.yaml file. This is a definition of our table model for use with the Lending Club loan data that we would download from Kaggle. This is the same data set we used in previous videos in this series. In this configuration file, we actually have two basic sections. One of them is the output, where we select a particular column from the table of data that we've downloaded and note it as the output column. This is going to be categorical or one-hot encoded data that will give us a class on output. The second big section in the file is the input. This actually labels in name value pairs here in YAML every column that we have in the data set and provides a type of how we're going to parse that data in order to turn it into a tensor for machine learning. We have three types going on here: a numeric type, a categorical type, and a percentage type, the same kinds that we used in the previous videos. And now we'll take a look at the code that turns this YAML file into an executable table model. Some of this code is familiar from previous sections in the series, and we're just expanding this to work with a more data-driven or declarative approach in YAML. You can see here the definition of the table model, which should be familiar from before, where we import the table classifier, table model, we have pandas, and then we lay out in data a series of values, named columns with some percentage, some numbers, and some categories. And then the transformers, where we use particular objects to go from input to output and then configure our model, which will generate matrices. Now the big difference we're adding in this time is a class method to load from configuration. This is on the table model class itself, and it's going to take an object that is the configuration. In this case, the configuration will load up from YAML into a dictionary in Python, and it's going to have keys input and output, and then a key for each individual column that occurs in the table of CSV data. Then we'll go ahead and take this and pass it into a mapping function. So for each one of those named column types, it actually aliases the Python type that we're going to be using in order to handle that column. See the numeric column here, it just goes from the name numeric to the numeric column. You see the percentage name here, which goes to the percentage column, which turns it into a range of 0 to 1 rather than having the percentage sign going on. And then finally we have the categorical type, which maps to the categorical column that takes our values, which would be, say, names and strings, and label encoding them, and then one-hot encoding them for use in machine learning models. Now by setting up with this configuration file, we don't necessarily have to write a new Python program each time. We just use this from configuration function to go over all of the column name maps, look up the types, and then with the parentheses right there, we're actually constructing a new column and putting them into name value pairs, and then using the class, in this case table model, passing in the configuration that we loaded up from YAML. So this is just a way to have a factory method that turns a YAML file into a series of Python objects to create our table model. Now we're going to make the entire table classifier module executable by providing a main module at the root of the table classifier folder that checks to see if this is being invoked as main, and then hands off execution to a CLI module that defines the command line interface. Now the CLI interface is actually using one of my favorites, which is docopt, that lets you declare the parameter parsing for a command line program as a GNU style help input. So here you can see the usage where I have two modes, train and serve. In the train case, we take our configuration YAML that we just looked at, an input data CSV file, such as the Kaggle data that we downloaded, and it'll finally output a trained machine learning model. And then in the serve mode, it just takes that trained model and puts it on a port. So you can see we just call docopt with the doc string, which is the string here above, and then if the arguments get parsed into a hash, and then we just see whether we're on train or we're on serve, delegating down to two separate modules, in this case a trainer module and a server module that perform the actual command line program actions. For now, just remember that we'll have a video on the training using a Docker container and the serving using a Docker container, and we'll dig into the code in the server and trainer modules in those videos when we get to that point.